Good day. Today, we will talk about a web service that can help us to predict blood stage malaria inhibition. This project was developed as a tool that can help in the design of safer and affordable malaria medicines. The web service is Malaria Inhibitor Prediction, also known as MAIP by its acronym. The details of the tool are in the following paper that I put in the description section, but in this video I want to focus on the use of the web tool. The link to the web service is in the following direction. Before we talk about MAPE, I want to introduce malaria. According to the World Health Organization, malaria is a life-threatening disease caused by parasites that are transmitted to people through the bites of infected female Anopheles mosquitoes. It is preventable and curable. First, we need to load the main page. Here we can see a short description of the project and a section where we can upload our file to evaluate compounds. In the following direction, we can see a tutorial for the web service. The file that we are going to upload needs to be a CSV or comma-separated value file that include in the first column the ChemBL ID and in the second column the SMILE ID for the compounds. So we are going to upload the file and after that we select the Run button. When the results are ready, we can download the output file that also is a CSV with 4 columns. The first and the second are the same of the input file. The third is a SMILES type descriptor used by the software and the last one is the model score. The higher the score, the more likely the compound will have an activity against malaria. Here we have showed the raw CSV, but to make it clear, we are going to show the head of both files with format. In the first file, we can see the ChemBL ID and the SMILES. In the output file, we can see the same first 2 columns and the standard SMILES for the code and the model score. Moreover, in the result description in the web page, we can see a plot that describes the distribution of the predicted scores for the compound in our dataset, and a resume chart of the results that compare 2 performance metrics with the validation datasets used in their project. First, we have the ROC AUC score that corresponds with receiver operator characteristic and area under the curve scores. This metric is often used to measure the performance of classification models. The second metric is the Enrichment Factor, or EF by their acronym. To obtain ROC-AUC curve, we need to plot the true positive rate, also known as TPR, against false positive rate, also known as FPR. The equations for both values are presented here, where TP corresponds with true positives, Fn corresponds with false negatives, and Fp and Tn correspond with false positives and true negatives respectively. This curve represents the capability of an algorithm to distinguish between 2 categories. If the algorithm can perfectly distinguish between both cases, the ROC-AUC curve will be like the red plot, but the real situation is that the algorithm could have problems to identify some elements, that is the green case. A better explanation can be found in the reference. Here we present their equation that corresponds with the hit rate or the proportion of active compounds within a defined sort fraction divided by the total hit rate. This last metric can be evaluated for different fractions of the dataset. So, an EF 10% corresponds with the enrichment factor for the first 10% of the dataset. To conclude, in words of the authors, the key output from this work is a practical tool that we hope will be of value in the global search for new malaria treatments. Also, they said, MAIP is a comprehensive open source software capability for molecule standardization and model building based on the widely used RT-Kit library that will enable other groups to build their own models. Without nothing more for the moment, thank you very much and have a good day.